My name is Derek Chen. I am the CEO and co-founder of Soletta AI, and we're building AI agents that you can trust. Soletta is SOLEDA.ai. And yeah, I'm really glad that Joel actually mentioned earlier today about doing contact center AI, because that's exactly where I used to work in this kind of space. And there's exactly this kind of push and pull between I want the agent to do exactly what I want and control it, but I also want it to do all the flexible, cool new things that generative AI can do. And so today's talk is really going to be about, can I get the best of both worlds? Can I get a lot of the traditional machine learning that I'm kind of used to with high accuracy and high controllability, but also get a lot of the power and flexibility that comes with all of these new LLM technologies? So getting into it, I guess I should make a little quick intro of myself. I'm a research scientist in dialogue systems, turned founder, and I've been studying this for like about the last 10 years in academia at like Stanford, Berkeley, UW, so on and so forth, and I've also applied this to real life applications. And one of the common themes that I've seen is that when you're working with AI, the goalposts tend to move a bit. And so in particular, there's this quote that says that as long as it works, no one calls it AI anymore. This is a quote from John McCarthy referring to Deep Blue. Does anyone know what event preceded this quote with Deep Blue? Anyone? Audience? Chess. That is correct. This is when Garry Kasparov got beaten by Deep Blue with IBM. And so this has been a few years ago, but now when you have something that beats a chess agent, it's like, not a big deal. It's not really AI anymore. Even in my tenure with just like the last 7 to 10 years, it's like, oh, well, now like if you can beat a Go kind of thing, well, no, Go is like 5 years ago. That's not AI anymore. And when I started, being able to like recognize cats and dogs in pictures was considered cutting edge AI. And now we're generating pictures of cats and dogs, so that's no longer AI either. And so what I really want to go into today, though, is to kind of highlight the point, though, that outside of Gen AI, there is this larger field of machine learning. So like, what is that? How does that work? I want to also talk about how does this compare to generative AI? And what can you do with this as a marketer, right? Because this is an AI and marketing event. So digging into it, traditional machine learning is training a computer model to learn a task directly from data rather than being programmed to do so. Now, this is actually pretty revolutionary because if we think about classical programming, what we see is that you're feeding in a number of rules, usually a bunch of if-then statements, and then out of that you get some answers. And so, for example, if I want to tell that something is a cat, I might say like, oh, is there some ears on it that are pointy, or is it like round like a dog? Is there some tail? Was the fur color, is it orange? Those are the kinds of rules that I might create. But when you feed this into machine learning, instead what you do is you flip it on its head, and you give in data plus the answers, and then the machine learns for itself what those rules should be. Like, all of a sudden, you're not manually crafting a lot of those details, and instead you're letting the machine do the work for you. So this is pretty revolutionary. Now, who here also knows that there's many other algorithms out there more than just LLMs, right? Because it used to be that there were many other things that could occur, such as this diagram here, which is a decision tree. There's also things that are like neural networks, or naive Bayes, or k-means clustering, or deep learning. Who here has heard of some of these algorithms before already? There you go, like everybody, right? So we know that these things exist, but we don't hear about them so much anymore. Who knows the difference between neural networks and deep learning? Anybody? Anyone call it out? Okay, audience in the back, go ahead. More layers. Okay, we'll go with that. So a traditional neural network might take something as input, such as this image of a car right here, and then perform some sort of feature extraction. You then feed it into a feed-forward network for classification and then decide if there's a car or not a car. Now, deep learning came around and said, oh, let's add more layers. But what was the practical application of this? The practical idea actually is that you no longer need to do a lot of the manual work with like feature extraction, where you have to say, oh, there's a tire here, or a lamp here, or a windshield here, or a car door here. Instead, you can just feed in the raw images, again with those labels, and you get an output. And the output is actually surprisingly good. And so this is the kind of advances that we've seen in the last 10 years and have only continued to get better. Now, as we move forward though, because there's all sorts of these algorithms, something that you might want to be able to do is be able to categorize them, right? Like, how am I going to make sense of all of this? There are different ways to look at this, such as supervised versus unsupervised learning. So for example, k-means clustering is unsupervised, k-nearest neighbor is supervised. There's also very popular techniques of like NLP versus computer vision, right? These are the things where you're generating images versus generating text. But for today, what we're really going to be focusing on is the difference between generative AI versus discriminative AI. So let's dig into this then. What is generative AI? How do LLMs fit into this picture? And maybe most importantly, like, what can you do with it as a marketer? Generative AI is just machine learning models that learn patterns from large data sets and then generates new data that follows those patterns. Mathematically speaking, you can view this as the joint probability of x and y, where you can assume that x is your input and y is your target output. And if x is your input, you might say it's something like 99 pixels out of a 10 by 10 image, right? And so what is y then? Y here is the RGB values of the very last pixel. And so what you're intuitively really trying to do here, though, is you're really trying to say, what is the entire distribution of pixels within the domain of interest? And you're looking at the full probability distribution of x and y. And so in this case, we might have to ask something like, what do all cars have in common? If we know that, then we know how to fill in that last pixel. If we go a little bit broader, we might say, what do all transportation vehicles look like? Now I'm looking at all planes and trains and cars and subways, so on and so forth. Now we bring this home a little bit more, we might have to also ask ourselves, what do all display ads have in common? What do they look like? Can we learn something from this? Can we generate something from this? And if we use it more for these LLMs, we might move to the text domain, where now it's the entire distribution of tokens within the domain of interest. We might say, what does all ad copy sound like? Now, if we expand this to the full set of text, then we might say, what does all language have in common? That's exactly what gets us a large language model. Now, large language models are a type of generative AI, and generative AI has been around for a while. Even traditional machine learning includes generative AI. But these days, generative AI is probably the most popular form. LLMs is the most popular form of that, and this is a type of deep learner. It's deep because back in 2012, AlexNet had 8 layers. And just a few years later, that quadrupled into 19 layers, 24 layers. And then it was 152 layers with ResNet. These days, we have tens of thousands of layers in these transformer blocks. It's even hard to really count how that really works anymore. There's so many billions of parameters, we don't know what's going on. It's very, very deep. Now, how do you train a language model? It turns out, though, this type of algorithm is actually quite simple. It's simply next token prediction. And how does next token prediction work? Well, let's assume that the conversation starts with the word I. Okay, now let's predict the next token. Anyone want to shout out what comes after I? Am. Okay, that's a good one. How about I love? Okay, what do I love? Let's pick one more token. You, okay. I'm going to go with AI. And what? Food. Okay, it's marketing. Okay, we're here for AI and marketing. Okay, all of your guesses are very reasonable, though. Okay, we're going to do maybe 2 more. Let's see if you guys can do better this time. I love my what? Dog. That is perfect. That is exactly right. You're reading my mind here. Now, some people might also say something like, I love my job, but then you'd really start to question that. You're not really sure what that guy means. Okay? But these are examples of, relatively, the first one was higher perplexity, meaning you didn't quite know what came after it. Now you have something in the middle. And here I'll give you one with lower perplexity. Maybe it's easier to figure out what the next token might be. I love ice what? There you go. Everyone understood that one. There's I love ice cream. So this is exactly what the language model is trying to do when it's being trained. It's just predicting the next token. And if it's able to get a very low perplexity score or equivalently very high entropy, then it's able to figure out exactly what it needs to be able to do. The idea, though, then, is I also want to translate this into training a foundation model. So what do I have to do then? Well, beyond predicting the next token, I also now need to be able to follow instructions rather than just predicting the next word. I also need to be able to adapt to human preferences. This is done through a technique called reinforcement learning from human feedback. For the purposes of this talk, this is a little too complicated, so I'm going to put that to the side. But if there's anyone afterwards who wants to dive into the technical details, I'm happy to do so. Now, given large language models, what can we do with this as marketers? Well, the most common thing is something like content creation. We've already seen a number of startups, frankly, people who've presented in this group, that are creating copy and emails, social media, blog posts, and other forms of long-form content. Another common use case these days is personalization. We've also, I think, just talked about this today, where you can craft tailored messages for customers based on their personalized preferences. You can even do this on the fly by just seeing how they interact with your website and dynamically changing things like the call to action. Like, what were they hovering over? What should I be going after next? The next thing is maybe ideation. You can also use generative AI for brainstorming creative campaign ideas and product concepts. You can even use it for designing user personas and simulating user reactions. That's awesome. So what about the other half of this? What about discriminative AI? So this next part, I'm going to be talking about what is this, how does it compare to Gen AI, and also, once again, kind of what can you do with it. At a high level, you can almost think about it as like drawing a line in the sand, where on the left side of this, there's some like bluish, greenish thing, and on the right side, there's some like orange, yellowish thing, and so I'm going to discriminate between these two sides. So what is discriminative learning? It's really models that learn key features of different categories from large data sets and then classify new instances based on those features. Mathematically speaking, now we're looking at the conditional probability of y given x. So once again, let's assume that x is your input, y is your target output, and so x here might be all the pixels within an image, and your output y is like, what is the animal shown in the image, right? Is it perhaps a dog or a cat or a hamster or something else, right? So intuitively, what you're trying to do this time is you want your model to figure out the decision boundary between the different items that you're trying to categorize. One of the powerful things here then, as a little sneak peek, is that it's not going to choose things that are outside of what you're going to categorize. If you're saying these are the things to choose from, it will really only choose from those things. So that's a level of control there that you can't get with other types of models. You might also want to ask things like, given the colors and shape of this logo, which brand do I represent? Because we know that brands have different types of feelings, and sometimes even looking at it without the text itself, you already know what's going on. You might want to ask these days, given this email text, is the writer a human or an AI? This is a discriminative type of question. And you might say, more practically speaking, given these conversion metrics, which campaign should I be using to increase my spend or decrease my spend? Now, given this in a more visual form, we can look at generative AI as saying, I have all of these points in some vector space that's in some sort of embedding. And what I'm going to do is I'm going to sample one of those points anywhere within this space. And if my model is trained correctly, I should be able to draw something out that looks pretty reasonable. So in this case, it's like maybe a picture of a cat on one side or a picture of a dog on the other side. But you don't really know what you're doing until you sample. On the other hand, a discriminant model will say, I don't actually know what's exactly going on at each point in the embedding space, but I do know that there's a line down the middle, so I can tell you that if the point is on this side of the line, it's probably a cat. If it's on the other side of the line, it's probably a dog, and that's all I need to do. So that really leads directly into the strengths of each model type. A discriminative model usually has fairly high accuracy. That's because all the model power is pointed directly at training it to do the tasks that you care about. I'm only trying to do like dogs versus cats, so I don't need to model the full distribution, and I can do my job pretty darn well. This also means that you get really high efficiency because the computational resources required to train a model of equal power is usually much smaller. And as we mentioned earlier, this also gives you quite a bit good of control. These kinds of models set up in the correct way don't really hallucinate, since the models only choose from the set of options that you provide as classes. Now, one of the things that we've heard a couple of times with generative AI is that they hallucinate. But hallucination can actually be seen as one of the strengths because it allows those models to be creative and come up with new ideas that have not been considered before for novel applications. It's also great for diversity because generative models allow you to sample from the distribution to produce diverse examples for cases such as data augmentation or interpretability. What's really great is that when you have these types of models, they're actually also quite flexible as well. Even though they've been trained just to model the full distribution, you can use them for cases beyond what they've been trained for, including classification. You can actually use generative AI for discrimination if you know how to set up the Bayes rule and some of this other mathematical setup. So it's pretty powerful. And what we'd really like to do then is maybe somehow combine them. And what I'm going to talk about first, though, is still just applying discriminative AI in some of these use cases by alone. So with discriminative AI alone, one of the things that you can do is customer targeting. You might want to use it to decide which customer segments are most likely to click or buy. You can also look at it as trying to predict customers who will churn or those who will retain, and then be able to launch some sort of plan of attack before it's too late. This is also helpful with lead scoring and prioritization, because then you can score your leads and you can forecast how much a candidate customer might be willing to pay. These are all very practical, real-life use cases that you probably have seen or maybe even already do at your companies. And finally, another very common one is sentiment analysis, where you're trying to monitor for positive or negative, right? This is the discrimination part, type of news around your brand. Or you just use it to analyze customer reviews or feedback at scale. So as we were teasing earlier then, is there a way to get the best of both worlds? And the spoiler alert is yes. In fact, we're going to be kind of showing a demo of some of this later today, and also kind of wrapping up with, again, some marketing applications using everything together. So before I get into that, let's set things up a little bit. If we're trying to get the best of everything, then we first must realize that many training algorithms and modalities exist, each with their own trade-offs. But for each one of these algorithms, they can't be two things at once. That is either discriminative or generative. So if we want to get the best of everything, what we're really talking about is a system that contains multiple models. Each of their models is one type or the other, and we try to mix them together in the best way possible. One of the ways that we can do this then, when we do this properly, then we can get the best of both, because the traditional methods are highly accurate and fast, but historically could not handle the long tail of requests. The new foundation models are flexible enough to fill in the blanks to actually deal with some of those long tail items. And so when we do that correctly, we might see something that's the best of everything. One application of this is actually AI agents, when done correctly. We've seen a lot of companies only do the generative AI side, and they are having all those strengths, but also all those weaknesses. So trying to mix them together is actually quite powerful, and that's exactly what we do at Soletta. We really are trying to build an agent that avoids hallucination by predicting, explicitly, the user intent. And that really just means choosing from the intents that we give it, and so we know it's not going to choose from outside of that set. We're also able to overcome false assumptions by relying on classic approaches to dealing with uncertainty. And at the same time, we're taking advantage of generative AI to handle edge cases with dynamic neurosymbolic reasoning. So really just trying to get the best of everything. The use case that I'm going to kind of show you, I guess I should talk about the use case of the company as a whole. Really, we're trying to build an AI agent that's good for data management in spreadsheets, because a lot of you guys have to deal with spreadsheets, and really you should be working on marketing, not data cleaning. And so a lot of what the agent does is it does data cleaning and preparation for marketing analytics. It's also integrating information together from different marketing channels, such as your LinkedIns, your Googles, your Facebooks, so on and so forth. And finally, wrapping it all up in some sort of analysis and reporting in a verifiable and repeatable manner. The first example that I'm going to show you is how to figure out the conversion rate with a specific metric definition. This is actually quite useful because every company maybe has different ways to calculate this very common metric. And if you were only to use generative AI, it might blindly make assumptions about how your company defines conversion rate. It also fails to account for messy reality. It likes to just usually jump in and talk, right, as we've all seen. And so this ultimately will lead to plausible sounding, but ultimately incorrect answers. And really, you want to use a little bit of that discriminative side to balance that out. So now I'm going to switch over to a demo of my app. This is kind of scary because we're not fully tested yet. So bear with me if there's any sort of hiccups, but let's give it a shot. So I guess what I should say first is that this is a spreadsheet with information about activity types of users coming in. This is like your classic streaming logs. You've got some activity data, different types, you've got some times, you've got your URLs where they're coming from, so on and so forth. You also have things like the purchases table, which includes different product IDs, different quantities. This is actually just a spreadsheet, so if you wanted to change stuff, you can go ahead and do that. But I'm going to go ahead and just ask this question first, which is, what is the conversion rate for users from Yahoo? Now, what should happen is Dana, who's our agent, should start to think. And the key point to kind of call out here is that Dana doesn't actually give you an answer. That's kind of surprising. So what's going on? So behind the scenes, Dana says that to calculate the conversion rate for users from Yahoo, we should start by filtering the activities table using the refer URL column to identify visits originating from Yahoo. The activity type column, this one right here, in the activities table is likely the best candidate to determine visits because the formula for conversion is supposed to be conversion over visits, right? But how did we decide what is a visit? How did we decide what is a conversion? So this is not totally known. So what Dana is actually doing is not giving an answer and saying, should I use visit site or view product from the activity type column to determine visits? You should use visit site to determine visits. And additionally, is there any criteria for conversion? And use purchase activity type as the conversion. No need to join with the purchases table. Okay, so this is really a sign here of the fact that the agent is truly trying to understand you before moving forward with something. And then should I use purchase activity even though it's not? Yes, use the purchase activity type for conversions. And it's going to do some more thinking, and it needs to do some more clarification. Hopefully, let's see what happens this time. We should filter it. Okay, I'm still having trouble understanding your request. Like, Dana's just really making sure that we understand what's going on before moving forward. And so now we might say, well, conversion depends on activity type. It also depends on user ID. The visit also depends on activity type, and it also depends on the referrer ID because it's supposed to be users from Yahoo. So I really want to now filter for users from Yahoo. Oh, we also have to select a time range because we didn't tell it what time we should really choose from. And so now we're telling Dana, please use all available data without any restriction on the time range. Now we get an answer. See, so this is really the distinction here. We're not just using generative AI to like spit out something. We're really discriminating step by step by step. Do we have all the information possible? Do we have the conversion part? Do we have the visit part? Do we have the formula part? Do we have the time range? And then being able to put all of that together. Very cool. I'm now going to show you a second demo. So I'm going to show 3 short questions. Hopefully this will go. We're going to say something like, so in this table, we have some order data from different products, different customers, and sizes. What kind of things is this? This is actually different shoe sizes and shoe brands. So there's different styles, there's different brands, there's different costs. We might also say, what is in the customers, what data is in the customers table? And over here, this should be pretty straightforward. So Dana will go ahead and answer that question. The customers table contains 584 customer records with personal information, including first, last, so on and so forth. And also kind of jumps to that column and that table to really pinpoint, yeah, I know exactly what you're talking about. You were on the products table, but now you were talking about customers. It's very cool. Let's go ahead and ask a question though. Please show me the average, what did I want to ask? Revenue we made each month in 2023. Okay, so now Dana should be able to do a little bit of thinking behind the scenes once again and calculate that and give you an answer. the average revenue we made each month was so on and so forth. It gives you a nice little summary. It's not spitting out tons and tons of information because you already have that information right there. Dana is smart enough to recognize like what does a normal human interaction look like and kind of truncate that a little bit. As we move forward, though, we can also do other things over here, such as saying like, oh, can you split the date column into month, day, and year? And so this is just really another request. And then Dana will go ahead and do some thinking as usual. And sure, I've made the changes. And we can look at this, and it's actually fairly complicated. Once again, you have to like decide how to do this, and the month, and day, and the year, create those columns, so on and so forth. So there's a lot of stuff going on. What the next thing I want to show you, though, is really going to highlight this discriminative versus generative nature. I'm going to say, please show me the average revenue we made each month in 2023. And I'm going to start this over to ask the exact same question. But this time, I'm going to control my agent in a way that behaves a little bit differently, which is something that you can't really do with normal agent. And so I'm going to just basically paste this exact request, but because I've given it a little bit of a push towards something, then it also knows that in addition to just querying it, I also want to see a visual. I also want to see a graph of it. And that was basically guaranteed. I can do this 100 times, and every single time it's going to listen to this. Now, if I said the words a little bit differently, then there's some interpretation. But this is the type of control that you can have when you're running with discriminative AI. And then as one last thing, I'm going to do this one last way, is 2 points. I'm going to copy and paste this piece of text because this is written as Gen Z speak, which I do not speak fluently. What you have actually said to the agent is, yo, AI bestie, could you do me a solid and like vibe check the average sales for each month? Just need those monthly T-spills for the Riz, you know? And there's like little emojis and things like that. But ultimately, it's asking the exact same thing that I asked 2 other times before. It's asking for the average revenue per month. And this time, though, because there's still generative AI in it, it's flexible enough to still give you those answers. So here's the monthly average T-spill for you. January was blah, 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 and gives you exactly in that style what you want it to do. And then you can also go further. Let's see if there's one last thing. This might be too much, but let's give it a shot. Oh my God, you're the real MVP. Those stats are fire. But like, what's the T on the kicks themselves? Which shoes are like the main character here? Give me the deets on who's slaying, who's getting ghosted. Okay, this is actually a pretty tough question, definitely not written in a professional tone, but boom, Dana's just smart enough to figure it out, okay? The main characters in the shoe are Converse kids running shoes with a total sales of $990, Converse men's, and Steve Madden women's. These kicks are definitely slaying the scene. All right, that's the demo. I'm gonna wrap things up now. So as you've seen, one of the things that you can really do when you mix everything together is AI co-pilots for productivity. This is exactly what Soletta is working on. We're starting with an agent for data cleaning, integration, analysis. We're going to be moving on in the future to things related to presentations, email, calendar management, so on and so forth. As a marketer, you can also use chatbots and AI yourself as well, maybe for combining data for context-aware chatbots. You can also use everything combined together for things like forecasting. Like, for example, generating possible scenarios and synthetic users with foundation models, then using discriminative models to take advantage of those techniques to predict who is likely to convert. All in all, hopefully, we've been able to show you the superpower of putting everything together with traditional ML and generative AI. All right, that's it. Thank you so much. Yeah, so the idea here then is that before I pass anything into like an LLM piece, what I'm really doing is something called NLU, Natural Language Understanding. And the Natural Language Understanding module is fine-tuned to only do classification. And the types of, it's actually fairly complex because this starts to get real, but at a high level, the classification it's doing is, let's say I have 10 different types of user intents, 10 different buckets that I can go into. And I'm going to categorize it to one of those intents before deciding what kind of actions to take. And it's that first discriminative part which is really critical because I don't want it to choose something that I can't handle. This is also one of the key differences that we do with Dana is because it's not just a black box wrapper, we're actually explicitly capturing that information within our NLU module. And it's because we're explicitly predicting it with discriminative AI and capturing it, we can actually use that to store your user preference, your metric, and reuse that in the future. The waitlist is open. We're at Soleda AI, Soleda.ai. And if you check it out, I'm happy to put you to the front of the waitlist and let you guys give it a spin.